So this is the electricity homework booklet question 11. So we've got a circuit diagram showing an LED connected in series with a resistor and a 3-volt battery. There's the LED, there's the resistor. And the first thing we're asked to do is to calculate the resistance of R. So my first instinct is to think in terms of V equals IR, and we know I, that's great. What we don't know straight away is the PD across that resistor. But we can work it out because we know we've got 3 volts from the cell, so the total PD has to be 3 volts. We're told that the PD across the diode is 2, which leaves 1 volt for the resistor. R is V upon I, 1 over, so that 1 volt over the 10 times 10 to the minus 3 is 100 ohms. 1 mark for working out that it's 1 volt PD and 1 for getting the answer. Calculate the electrical power supplied to the diode. Probably the easiest way is just use P equals IV here, and it's a single mark, 10 times 10 to the minus 3 times 2, 0.02 watts. Since we've calculated the resistance, you could have used I squared R or V squared upon R as well. Then we've got to calculate the energy of a photon of that wavelength. Straightforward use of E equals hc upon lambda. Love it all in the sum. Total of 2 marks. It's getting through to 3.1 times 10 to the minus 19 joules. In the sum, I'm pretty sure, yep, I've only got speed of light to 2 significant figures, so hence my answer to 2 significant figures. We're then asked to estimate the number of photons supplied per second by the diode. Well, we've got to think back here to the power we worked out back in part B, and remember that power is the energy per unit time, or the energy per second. So in 1 second we've got energy equal to the power 0.020 joules. But we can also think in terms of the energy being the number of photons multiplied by the energy of each one. So the number is the total energy in 1 second divided by the energy of each one. Works out to that value, 6.4 times 10 to the 16. We're then asked to state an assumption we've made in that last part. And there's a number you could pick up from there, number of ways you can put those as well. So we're assuming that all of that energy is converted into light photons. In other words, that the LED is 100% efficient. The other thing we're assuming is that all of those photons have got that same energy, that is, that the light is monochromatic. So any one of those 4 statements for the 1 mark. So that's the electricity homework booklet question 11.